What up, what up? Welcome to Back to Basics. This one's going to be a short and sweet video about notations for transformations. Now, I teach out of the Pearson enVision curriculum 2018, and instead of saying, hey, let's move this shape 3 units that way and 4 units that way, they give you things that look like this. So if you're taking a quiz for Pearson, or if you're taking a test and you see something that looks like this, and you're like, the heck does this mean? I'm about to show you. Okay? So there's 3 types of transformations that we see primarily in geometry. And the first one is a translation. A translation is a simple movement. All right, this guy goes from here to here. So that shape goes from there to there. Maybe it goes up, maybe it goes down, but the shape shouldn't change size. Now, the way they tell you how many units you move a shape on a coordinate plane is they use a capital T. They use these little slanted less than greater than symbols and an X and a Y value to tell you how many units you move. The first number that it gives you tells you how many units you move right. If it was negative, you'd move left. The second number tells you how many units you move up. If it was negative, you move down. Okay, now we'll look at examples in the next page or slide. But that's what a translation looks like. T with the little less than symbol, a number, another number greater than symbol. Okay, I thought I had that backwards for a second there. I did. Reflection looks pretty simple. Capital R, and then it tells you the axis that you reflect it over. So maybe it'll say x-axis, which means you reflect it over the x-axis. For example, if this was a coordinate plane, and I said, take this smiley face and reflect it over the x-axis, it would look like that. Okay, that would be capital R, x-axis. If it said y-axis, then you would flip it sideways. Maybe it says the x equals 3 axis, which makes you do a whole lot of work. And if you're confused by that, I have videos on that. Look it up. Rotation is probably the grossest one and the most obnoxious one of them all. It'll be a little r, lowercase. It'll give you a direction that you rotate counterclockwise. Now you might be thinking, why not regular clockwise? Why counterclockwise? When you get to pre-calculus, if that is your ambition, any angle that you measure is going to be done in a counterclockwise motion. Why the math people chose it to be that way? No clue. But when we are doing rotations in geometry, it's the same thing, counterclockwise movement. Most of the times this will be 90 degrees, 180 degrees, or 270 degrees. And then it'll give you a point that you could rotate it around. If the point that it gives you appears to be a letter O, then that means you're spinning it around the origin. If it gives you a point like 3, 2, that means you go to 3, 2 and spin it around 3, 2. Again, if you're like, I don't understand, I have videos on that. Look it up. And then like, and then subscribe, and then hit that bell. But anyway, let's do a few to make sure that we feel comfortable. Describe each transformation in words. We first see a lowercase r. That means a rotation. We see 270, so 270 degrees counterclockwise. And that O means that I take it and spin it around my origin, which is 0, 0. That's the first one. The second one is a T, which means translation. Now, the first number is -3. If it was positive, we'd move right 3. But since this is negative, we move left 3. The second number is 4. If it was positive, we'd move it up, and it is. So it's up 4. If this was negative, we'd move it down. But this is translation, left 3, up 4. The third one is a capital R. That is a reflection over the y equals -3 axis. Now what that means is we just draw a line over y equals -3, which is horizontal, and we take our shape wherever it may be and rotate it. Again, if you're not sure what that means, watch some videos. It'll all make sense. Last but not least, we have a lowercase r again, which is a rotation. This one is 180 degrees. 180 degrees means maybe I should say counterclockwise, but if you spin something 180 degrees, you're just spinning it a half circle. So it doesn't really matter the direction, so I won't even say it. Plus, I don't have enough room anyway. I'll probably run into my face, and you need that. That's the moneymaker. So we are going to rotate 180 degrees, no matter which direction, around not 0, 0, but the point 3, -2. Okay? So let's take a look at two examples. We'll answer them using this new notation that we're aware of, and we'll call it a day. Look at that. That means I'm almost done already. Describe each transformation in notation form. Let red be the original shape. All right, so with this first one, red is over here, and then it appears over here. Now, did I just take this shape and move it? No. It looks like I reflected it, and I used this line right here as my mirror. Now, how do I know that line is my mirror? Because this is 1, 2, 3 dots away, and this is 1, 2, 3 dots away, which means the y-axis is my mirror. So I would write this out as capital R. What did I say? Y-axis. I almost put just axis there. Raxis. But this is R, Y-axis. Reflection over the Y-axis. This guy is not so fun. Red is the original, and then all of a sudden it kind of flops down. Now, it's definitely not a reflection like that. It's definitely not a translation because it's sideways. It's a rotation. But how do I get this from standing up to falling down? Well, it almost appears that that guy is like, if I were to be the red block moving and I tripped over that point right here, 1, -3. So this shape is spinning around 1, -3. So it's a lowercase r. Now, it spins a quarter of a turn, which is 90 degrees. And the point that it spins around is 1, -3. All right, so this is transformation, I guess I should say, notation. And this is specific for Pearson enVision. So, you may use different books that have different things. You may look online and see different things. If you're using Pearson enVision and you see capital R, it's reflection, lowercase r, it's rotation, capital T, translation, just move it. And you know what? I like to do that. Move it. Move it. Thanks for watching. Bye.